Okay, for this example number 4, we're looking to find all zeros of the polynomial m of x equals x cubed minus 2x squared plus 9x minus 18. And we're also going to talk about the nature of the zeros, how many of them are real, how many are complex, and then we're going to factor m of x completely 2 times, once under the reals and once under the complex numbers. Before we can do that, we need to really focus on the first part, which is finding all the zeros. Now remember, in order for us to find the zeros of the polynomial, we're first going to start off and ask ourselves, what are the possible rational zeros? So what are our p's over q's? Now recall, p's represent all of the possible factors of our constant term, which in this case is negative 18, and q represents all of the possible factors of our leading coefficient, which we don't have one, so we can assume it's a 1. So what I'm going to do is I'm going to make a comprehensive list, first of all of our possible constant terms. So for 18, we have plus or minus 1, plus or minus 2, plus or minus 3. What else do we have? I'm just going to extend that line. 18 has a lot of factors. 4 is not a factor of 18. 5 is not 6's. 9 is. And then we have 18. So we have 1, 2, 3, 4, 5, 6 times 2 for plus or minus. So we have 12 possible factors in the numerator. And the denominator, because our q is 1, we're just going to call it plus or minus 1. So a list of all of these possible factors, dividing each one of these terms in the numerator by plus or minus 1 is just going to give us back the original term. So our possible factors are 1, plus or minus 2, plus or minus, sorry about that, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. So if our polynomial has any rational factors, it's going to be one of these 12 that we just listed. And remember, we find them by using synthetic division and checking to see if our remainder is 0 for any of them. So I'm going to start off, I'm going to use synthetic division. I'm always going to start off with my 1s. It just makes it a little easier. My corresponding, so we'll put 1 over here. My corresponding row matrix is going to be 1, negative 2, sorry about that, 9, and negative 18. Okay, so let's see if 1 is a 0, which means x minus 1 is a factor of this polynomial. So 1, 1, negative 1. 1 times negative 1 is negative 1. 9 minus 1 is 8. 8 times 1 is 8. The issue is here that we do not get 0 as a remainder, which means we can cross out positive 1 as being a possible 0. Let's check and see if negative 1 works. 1, negative 2, 9, negative 18. Okay, so let's drop that 1. 1 times negative 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is 3. 9 plus 3 is 12. 12 times negative 1 is negative 12. We get negative 30, so the answer here is no as well. So we've eliminated 2 of our factors. Neither positive nor negative 1 work. Let's move on to 2. Let's see if 2 works. It keeps doing this. Sorry about that. We have 1, negative 2, 9, and negative 18 again. Drop the 1. 1 times 2 is 2, which gives us 0. 0 times 2 is 0. 9 plus 0 is 9. 9 times 2 is 18. And fantastic. What this means is we found a 0 of our polynomial. So knowing that 2 is a 0 is equivalent to saying that x minus 2 is a factor of this polynomial. So that means that x minus 2 times, now remember this 109, what that means. Well, we took this polynomial, x cubed minus 2x squared plus 9x minus 18. So x cubed plus 2x squared plus 9x minus 18. Excuse me, I think this over here is a minus 2. So let's write that in there. And that is equivalent to saying x minus 2, remember, knowing that having 2 as a 0 means that x minus 2 is a factor, times, now we took x cubed, we divided by a factor of x, which means we're going to be left with x squared. This is our coefficient. So we have x squared plus 0x plus 9. We could just call that x squared plus 9. We don't have to put the 0x in there. So far we have one factor and we know that factor, we have 1 0 and we know that 0 is real. So x equals 2 is one of the zeros and it's real. Now let's talk about what our last two zeros are. So in order for us to find the last two zeros, we can solve this quadratic x squared plus 9. And what we can do is just set it equal to 0. Remember, to find the zeros, what we're doing is we're setting each one of these factors equal to 0. We subtract 9 from each side. We get x squared is equal to negative 9. Having x squared is equal to negative 9, we can take the square root of each side. Don't forget our plus or minus. And then remember that the square root of negative 9 is the same thing as saying 3i. So we have our other two solutions. One is positive 3i and one is negative 3i. Okay, so our polynomial, x cubed minus 2x squared plus 9x minus 18, has three solutions. The first solution is real, which is 2. The last two solutions are complex. One of them is 3i and the other one is negative 3i. So in response to the nature of the solutions here, we have one real solution, which we get here at 2, and then we have two complex solutions, one here at 3i, one here at negative 3i. Now in terms of factoring this completely, what that means, if we want to factor this completely under the reals, is we want to rewrite this so that we only have real coefficients factored completely. When we do that, we already know that 2 is a 0. That means we can write that as x minus 2. And then remember that x squared plus 9 are both real coefficients here. We have a 1 in front of the x squared and we have a 9. So this is what this polynomial looks like factored under the reals completely. This is factored under the reals. Now if we're going to go back and factor this under the complex, what that means is anything that's quadratic, which we have over here, we have to factor even further. So factoring this under the complex means we can have complex coefficients. So we would write this as x minus 2. Now remember, x squared plus 9 came from these two zeros. We have a 0 at 3i, which means x minus 3i, and we have a 0 at negative 3i. X minus negative 3i is the same thing as saying x plus 3i. So this is the polynomial factored completely under the set of complex numbers. Again, with reals, we have to have real coefficients, and with complex, anything that we have that is possibly quadratic can be factored using its complex zeros, which is what we have here.